Yes, good morning, all. Fifth semester chemistry elective. The title of the book is Agrochemicals, Organic Chemistry, Nanomaterials. This is the elective B. In this course, we are going to discuss about the agrochemicals, how the agrochemicals are came into light, how they are used, and what are the functionality, and how they place in the role of growth of plants. Uh, Next to the this agrochemicals is in two blocks, and organic chemistry is one block. In that organic chemistry, we are going to discuss about the pericyclic reaction, asymmetric synthesis, and uh, structural illustration of carbon compounds. Next, nanomaterials. In these nanomaterials, we are going to discuss about the what are the nanomaterials and what are the size of these nanomaterials, how they impact the size on the materials, and what are their how they are synthesized, how what are the properties, and what are the optoelectric properties, what are the applications of nanomaterials or nanochemistry are discussed in this nanochemistry block. Now I'm going to start the first block. That first block is agrochemicals 1. In that agrochemicals, the first unit, historical aspects of plant nutrients. Historical aspects of plant nutrients. Now coming to the first, for growing, these agrochemicals are using for the health and growth and sustainability of the plant kingdom, right? Not only in crops, we can also use the same in the various sectors of the uh, farm fields, right? Then we know that the plants are the source for the food for the animal kingdom, also with the human. What is the reason? Plants, can they manufacture their food material in the photo by using the photosynthesis by own? That food material is also utilized by the animals and human being. Therefore, most of the plants, they manufacture their own food by using the photosynthesis. By using this food, they can sustain, they can grow, they can ripe, they can give the fruits to the human beings and animals. Therefore, the plants, they can only they cannot only self-sustain, they can also sustain the living beings on the earth by providing the food. Right? For manufacturing this food material, plant needs some nutrients. That nutrients can be absorbed from the soil and from atmosphere. These elements can be utilized in the photosynthesis and other several biological functions in the plant, utilized for the growing and synthesizing the food. Therefore, it is well established. Most of the elements required, this whatever the nutrients are absorbed from the soil and atmosphere, or in the form of elements. That elements in the form of combined state, that may be in the salt forms. Those salt form of elements can be absorbed by the plants, then utilized in the food synthesis or food manufacture. Therefore, the elements required by the plants are also essential for the human beings and animals. How? For that, these two are animals and human beings are depends on the plants for food, because whatever the elements absorbed by the plant from the atmosphere and soil, that can be incorporated in the whatever the food synthesized by the plant in the photosynthesis, that can be consumed by the human beings and animals, the same will be transferred to the or gained by these mm, living beings are utilized in their metabolic process and biological functions to sustain. Right. Therefore, food or fodder obtained from soil which is deficient in the nutrients may lead to the malfunction of the plant growths, or sometimes it may death, or it may be sometimes extincted. Therefore, we need to provide a sufficient healthy nutrients, or we need to add this nutrient to the soil or apply on the food plants to get absorbed the healthy elements for the photosynthesis of plant. Therefore, the required plant nutrients are to be added to the field in the form of the natural or a synthetic manner. Whatever the elements required by the plants can be incorporated or can be added in the form of natural manure. We are whatever the manure we are gathered in the food waste, plant waste, animal waste. Okay, that can be manured naturally. That matter is used for the providing the elements that will be added to the farms. Or sometimes natural manure may be not in sufficient amount. In such conditions, we can use a synthetic manures that is called fertilizers. We are using fertilizers. We are adding fertilizers that can be subsidize the whatever the deficient nutrients in the soil it will be compensated. Then the plant growth will be healthy. Right. Human beings and animals depends on plants for their sustainability or for their life on the earth. Like plants, like animals, also need food for their growth and development. For their growth and development, plants are also needs the food. That food can be manufactured by its own by the plants. Plants can manufacture their own food consisting of some chemical elements in combined form. That combined form may be salt or some compounds, right? Salts form of compounds or covalent compounds may be sometimes used. Okay, these are called plant nutrients. Whatever the chemical elements in the combined form are applied for the plant growth or correcting the deficiency of the nutrients availability in the soil are called plant nutrients. Most of the elements needed by the plants are also essential for the human beings. Whatever the elements the plants absorbed from the soil or atmosphere are also utilized by the human beings and animals for their growth and development. Because of humans have depend on the plants for obtaining the essential food or elements, it is necessary to see that plants receive these elements from their source of absorption. Plants which are absorbing the elements from the most of the from the soil. Therefore, we need to monitor whatever the plants or crops we are cultivating in the field or in the farm. We must assure that all the elements are available on the earth crust, earth soil for the growth or development of the plant that can be incorporated these elements in the food. That food is supplement supplied to the human beings and animals. If the food are obtained from the plant, growth in soil deficient, In some of the nutrients is consumed by the humans and animals, is if it is deficient, whatever the elements required by the plants as well as the human beings are all, and also animals, it is deficient in the food. Also, automatically the growth and development functioning is malfunction. Therefore, we need to correct it. Whatever the material, whatever the matter, whatever the chemical components, whatever the chemical composition, whatever the formulations we are applied for correcting this deficiency are known as are known as annuals or fertilizers. Are known as fertilizers. Some historical aspects of plant nutrients. What are the need of what are the some kinds of plant nutrients are generally seen. Use of manures such as farmyard manure or green manure, that is the plant waste can be degraded in naturally. That is called green manures and night soils. Whatever this night soil is captured from the lakes. After the drying the lakes, we are collecting that soil and some bones are, but it is not the sufficient quantity. Bones are also some of some amount is used as manure. Is to improve the yields of the crop. It is an old agriculture practice by the human being. All these things are ancient man learned by of his practice, but based on the practice in the long period of practicing or doing the cultivation on the farm field, he's observed. Based on his observations, he has applied some methods to overcome this. Based on his experience, he observed that these are the manures can be correct the deficiencies observed in the soil. Later, an attempt was made to understand the scientific principles underlying the plant growth by the use of various chemicals. After observations and some experimentations, human can identify some specific scientific principles which is underlying for the growth of the plant by the use of various chemicals. A rationalization of farming and the soil management is an important. It should be mandatorily emerged for the farm cultivations. Right. With the advent of the chemical research as applied to the agriculture sciences, there was a rapid development in the understanding of plant growth, substances, and mineral nutrients. Several minerals are needed for the plant growth and development are observed, understood by the scientists that can be applied that has applied and got succeeded for healthy growth of the plants. Next, a Theodore Dissous, Saussure, and Jean Baptiste Boussingault are two prominent scientists of the 19th century of they are explained that the need of mineral nutrients of the growth of the plants. These three scientists are demonstrated in the 19th century how these mineral nutrients are important for the growth of plants. They shows that source of nitrogen of our plants was the soil. For growth of the plant, the one of the important nutrient is nitrogen nutrients. The source of nitrogen for plants was the soil. Justin Wall Liebig, who is considered as the father of agriculture chemistry, he showed that the plants obtain the elements calcium, potassium, sulfur, and phosphorus from the soil and some gases, especially carbon dioxide from the atmosphere. This carbon dioxide is the a main carbon source for the plant, which is used for the food manufacturing by the plant in the photosynthesis. Liebig also showed that the essential nature of potassium in plant nutrition, and he suggested that the depleted soil fertility has to restored by the addition of some minerals to obtain a good. After first crop, the soil got weakened in the nutrients. Therefore, whenever we are adding potassium to the soil, applied to the potassium, it will be restored, and adding some other minerals also strengthen the soil for the second crop. For example, superphosphate. Superphosphate is introduced as a fertilizer by John Laws in 1840. The Greece showed that the plant disease called as chlorosis. Actually, Greece is the first person. He demonstrated that plants are also diseased. He observed and discovered that plants, a chlorosis disease is observed. He applied iron salts for rectifying this disease. Therefore, the necessity of the other plant nutrients was recognized by several researchers over a period of about 100 years ago. Some essential plant nutrients. Actually, the plants needs 16 elements for their growth. 16 elements for their growth. They are carbon. This is the carbon source from the carbon dioxide, hydrogen and oxygen. This is source from the water, hydrogen, H2O. This will be absorbed from the soil. And potassium, phosphorus, nitrogen, calcium, magnesium, sulfur, zinc, boron, copper, manganese, molybdenum, chlorine, and iron. These 16 elements are essential nutrients for the plant growth. The carbon, hydrogen, and oxygen are called natural nutrients because these are derived from the air and water. Carbon dioxide absorbed from the atmosphere, air, and hydrogen and oxygen is gained from the water. Next, nitrogen, phosphorus, and potassium consumed by the plants in large quantity. That is the main reason we need to apply these three nutrients as a additive nutrients, right? In large quantities. What are that? Nitrogen, phosphorus, and potassium are consumed by the plants in large quantities. These are considered as primary nutrients and also called as macronutrients. What are that? Nitrogen, phosphorus, potassium. These three nutrients are called as macronutrients. Next, calcium, magnesium, and sulfur. These are called as secondary nutrients. These elements needed only in minute quantities are classified as micronutrients, which includes chlorine, iron, manganese, boron, zinc, carbon, molybdenum, nickel are the mm, micronutrients. An average plant can contains these elements nitrogen, potassium in a ratio of, that is, we can express it in the form of NPK ratio 2 is to 0 is to 44, that is 0 uh, 2 is to 0.44 is to 0.83, or we can express in the form of nitrogen P2O5 is to K2O, 2 is to 1 is to 1 ratio. Okay. Next, classification of fertilizers and repeated cultivations. We are every year in some areas we can take the two crops. In some areas we can take the three crops. Based on that water availability, we can take the one crop. Okay, that is depends on the geographical advantages. Uh, Suppose if the farm field is undergone repeated cultivation, the soil is depleted. It is not possible to give the continuous nutrients, especially macronutrients, nitrogen, phosphorus, potassium. After one crop, the percentage of these NPK values becomes down. Therefore, the soil is depleted for the plant nutrients and it becomes less productive. Once the availability of this macro, micro, and secondary nutrients may be down, the amount of availability of these nutrients, obviously the crop productivity becomes reduced. This deficiency must be made up through addition of certain elements in order to improve the subsequent crops. These additives are called fertilizers. These additives are called fertilizers. The fertilizers are the supplements. These are supplementing the elements removed by the plants from the soil. They maintain the pH of the soil 7 to 8, that is almost in between the neutral and above somewhat neutral alkaline, a mild or weak alkaline conditions to facilitate the optimum growth of plants. Fertilizers are classified as follows on the basis of their action on the soil. Based on the action on the soil, fertilizers are classified into direct fertilizers, indirect fertilizers, complete fertilizers, incomplete fertilizers, and mixed fertilizers. Then what are direct fertilizers? Fertilizers that are directly absorbed by the plant from the soil is called as direct fertilizers. Fertilizer which can be directly absorbed by the plant from the soil is called direct fertilizer. What are that? Nitrates, superphosphate, and ammonium salts. What are the indirect fertilizers? Substance that helps fertilization by keeping an optimum pH of the soil for plant growth. Right. Whatever the manure, we have add manure, we can use it as indirect fertilizer. Complete fertilizers. Fertilizers which provide all the essential nutrients such as nitrogen, phosphorus. Guano is an example. Okay. Next, incomplete fertilizers. Substance which contain only one or two are the required elements, example ammonium phosphate and potassium nitrate. It are the incomplete. Incomplete means it can provide only one or two nutrients, not all. Such fertilizers are called. These are called sometimes specific fertilizers. Suppose the soil needed only nitrogen source, we can add ammonium. It requires only potassium and nitrogen, we can add potassium nitrate. If it requires only nitrogen and phosphorus, we can add ammonium phosphate. Like that. These are called incomplete fertilizers. Mixed fertilizers. These are prepared by the mixing of some appropriate quantities of fertilizers like ammonium fertilizer, potassium salt fertilizer, phosphate. This can be a fixed quantities are mixed and that will be applied on the soil for maintaining the nutrients concentration on the soil for the cultivation. Next to fertilizer sources. Fertilizers are two different types depending on their source. Natural organic fertilizers, natural inorganic fertilizers. Previously, we are classified the fertilizers based on the action of the soil, based on their action on the soil. Now we are classifying the fertilizers based on the source. Natural organic fertilizers, natural inorganic fertilizers, and artificial fertilizers. Artificial fertilizers we can also call as synthetic fertilizers. Okay, natural organic fertilizers. These natural fertilizers consist of plant matter obtained from the oil cake of cotton seeds, linseed and castor seeds, farmyard manure, compost of the dung of cow, buffaloes, and sheep. Animal matter such as powdered dry fish, dried blood from the slaughtered houses, as well as guano consisting of bird extinctions, fish bones, and fish refuses from the other important natural fertilizers. Okay, these are all these matter, whatever the matter collected from the animals and living being waste, including the plants, animals, and human beings, that will be combined and that will be manured, that is used as natural organic fertilizer. Next, natural inorganic fertilizers. These natural inorganic fertilizers generally we are taken from the a uh, mines. Chili saltpeter, rock phosphate, wood ash containing about 5% of potash from the important natural inorganic fertilizer. All these are most of the natural inorganic fertilizers are collected from the mines and some wood wastages. Okay, artificial fertilizers. These are also called as synthetic fertilizers, based on the essential elements supplied by them. These are divided into three categories. One is nitrogenous fertilizers. This nitrogen fertilizer itself indicates that it can. Yes. Based on the essential elements which they can supply, these fertilizers are classified into three categories. One is the nitrogenous fertilizers. This can supplement, this can be supplies the nitrogen nutrients, a nitrogen element to the plant as nitrates of sodium, calcium, ammonium, and potassium, also urea, ammonium sulfate, and calcium cyanamide. And a second class, phosphate fertilizers. Phosphate fertilizers. These phosphate or phosphatic fertilizers exemplified by the phosphate rocks, normal superphosphates, triple superphosphates, mono and diaminophosphates, and calcium metaphosphates. All these substances can be used for the supplement the phosphate or phosphorus in the soil. Okay, next to potassium fertilizers. The important potassium fertilizers are potassium nitrate, potassium chloride, potassium sulfate. Actually, if the soil is rich in nitrogen but deficient in the potassium, we can use potassium chloride and potassium sulfate. But here also we need to recognize, we need to check the pH of the soil. If the pH of the soil is the acidic in nature, sulfate chlorides can also increases the acidity. In such conditions, we need to maintain the acidity. pH. For that purpose, we need to use the required quantity only, not the more than excess. Okay, potassium nitrate can be used when the soil is deficient from the potassium as well as nitrogen. In such condition, we can apply the potassium nitrate. Next, manufacturing of urea. Urea is a formula is NH2C double bond O NH2. This is called biamide or guanamide, and we can also call guanamide. A white crystalline and hygroscopic solid. It is the solid, that's why it is having melting point. It can melt set to 130 to 132 degrees centigrade. And with about 42% of nitrogen, 45% of nitrogen is the one of the best fertilizer for supplementing the nitrogen for the crops. As urea is highly soluble in water, that is the advantage. The maximum absorption, maximum available for the absorption of the plants. That is the reason it can be used as readily available for absorption by the plants. Urea has a tendency to hydrolyze and to lose ammonia. It is manufactured by the reacting liquid carbon dioxide with the liquid ammonia in a silver lined special vessel to get the ammonium carbonate. And heating of ammonium carbamate at 130 degrees centigrade to 135 degrees centigrade in the high pressure, that is the 35 bar atmospheric pressure, urea is obtained. This is the ammonium carbamate. This ammonium carbamate heated at 130 to 135 degrees centigrade, that will leaves one water molecule, and dehydrogenation takes place, that leads to the formation of urea. Urea obtained in aqueous solution is concentrated in a vacuum evaporation. Whenever we are heating, water will be evaporated slowly. That vapors will be collected by the vacuum pump. That will be remove the water from the resulted mass. Slowly it will be solidified. When the concentration teaches about 99%, if falling filling type of evaporation is used to dry it completely by the use of hot air, the urea separates out as balls, globules. Okay, several variations of the methods for synthesis of urea is known. In all these methods, in general, basic step is treatment of ammonia with carbon dioxide in a reactor using a catalyst under high pressure at higher temperatures. The unreacted ammonia and carbon dioxide in the manufacture of urea are converted to ammonium carbamate, the unreacted ammonia and carbon dioxide. Both are inert at room at temperature, at atmospheric pressure and room temperature. But they are combined together. If you are applied pressure and temperature, they can react together. That produces the ammonium carbamate. This ammonium carbamate on subjected to the further different methods like applying heat and pressure and temperature, that will be losing the water molecule that leads to the formation of urea. Or if you are also treated with the HNO3, that leads to ammonium nitrate and carbon dioxide. This ammonium carbamate, ammonium carbonate can lead to the formation of ammonium nitrate. Okay. Next, the CO2 formed during the reaction is recycled. The HNO3 needed in this reaction is prepared by the oxidation of ammonia. The unreacted ammonia in the urea manufacture is also used for the production of ammonium sulfate by reacting it with dilute sulfuric acid. Ammonia is reacting with sulfuric acid that leads to the formation of ammonium sulfate. That is also used as fertilizer. Manufacturing of ammonium sulfate. Ammonium sulfate NH4 taken by SO4 contains about 21% of nitrogen. It is manufactured in India by two processes. As a byproduct of steel industry, ammonia is a byproduct in several industries. Ammonia is passed into the 60% solution of H2SO4 in lead-lined tank kept at 60 degrees centigrade. That is the reaction. Ammonia is dissolved in water and that is passed through or a dilute sulfuric acid. Through that, we are passing the ammonia gas or ammonia. We are adding ammonia that leads to the formation of ammonium sulfate and water. That coal contains about 1% of nitrogen. When coal is distilled in closed retorts, destructive distillation retort is a portion of the nitrogen is converted into ammonia and ammonia salt. That ammonia, whatever the ammonia is released in that reaction, is cooled down. That leads to the ammonia liquor. That ammonia liquor, uh, to that we are adding slaked lime. Slaked lime is added to the ammonia liquor and distilled. The liberated ammonia is absorbed into a sulfuric acid to give the ammonium sulfate. This is the expression of the reactions. Coal is on heating, it evolves the liquor ammonia gas that will be cooled, that leads to the formation of liquor ammonia. That liquor ammonia is treated with carbon dioxide and water that leads to the formation of ammonium carbonate. That ammonium carbonate is treated with the calcium hydroxide that leads to the formation of again ammonia and water and calcium carbonate. Next, ammonia is dissolved in the H2SO4 that leads to the formation of ammonium sulfate. Okay. Next, the second process is gypsum process. The raw materials used in this process is gypsum and ammonia and carbon dioxide and water. The process consists of mainly three steps: manufacturing of ammonia from nitrogen and hydrogen, the production of ammonium carbonate by reacting ammonia with carbon dioxide and water and reacting gypsum with ammonium carbonate solution to give ammonium sulfate and calcium carbonate. Carbon dioxide and ammonia. This is the reaction actually. Ammonia is reacting with carbon dioxide and water that leads to formation of ammonium carbonate. This ammonium carbonate is treated with calcium sulfate that leads to formation of the exchange of anions. Exchange of anions between ammonia and calcium that leads to formation of ammonium sulfate and calcium carbonate. That ammonium sulfate is a quick acting fertilizer. It is used in the paddy field at the planting time. Right. Next, manufacturing of superphosphate. Manufacturing of superphosphate. What is the superphosphate? Treatment of rock phosphate, calcium phosphate with sulfuric acid to give a soluble calcium phosphate called as superphosphate. This calcium phosphate that is also called rock phosphate. The rock phosphate is added to the H2SO4 and in water, that is the dilute H2SO4 you consider, that leads to formation of superphosphate, and calcium sulfate and water. Right. Powder superphosphate rock is mixed with concentrated sulfuric acid of specific gravity of 1.45 grams per liter, grams per ml in a cast iron mixture and poured into brick-lined pits. The mass is allowed to remain for a day. During the exothermic reaction, gases containing hydrogen fluoride, silicon fluoride, and carbon dioxide are evolved, making the solid porous. After several days, the material is dug out and dug out of the pit and powdered before bagging. During this process, a hard rock solid is generated that will be digged from the pits. Later, it will be machined to powder. Later, it will be packed into the bags. Right. Superphosphate normally contains about 5 to 8% of moisture. Usually, the plant nutrients consist of the phosphatic fertilizers is expressed as the percentage of phosphor. Rock phosphate containing about 33% or more of phosphorus pentoxide is to be used to get superphosphate with 20% available phosphorus pentoxide. Next, manufacturing of potassium sulfate. Potassium sulfate, K2SO4, contains about 54% of potassium oxide, whereas the commercial fertilizer contains 48 to 52% of potassium oxide, K2O. The available potassium from the potassium salt is expressed in terms of potassium oxide, K2O. Potassium sulfate is manufactured by fertilizer of high purity is obtained by treating the potassium chloride with concentrated sulfuric acid that leads to the formation of potassium sulfate. KCl is treated with H2SO4 that leads to the formation of potassium sulfate. This is the high concentrated potassium fertilizer. By dissolving langbeinite, that is the K2SO4 to MgSO4 in water, that solution is added to the concentrated solution of potassium chloride. The precipitate of potassium sulfate is separated out. A, a layer of liquid is decanted. The resulted solid is called potassium sulfate. Yes. This is the reaction. Potassium sulfate, K2SO4, and magnesium sulfate and KCl. This is actually seeding. These two get both are getting reacted. That leads to formation of potassium sulfate and magnesium chloride. The present trend is to produce mixed fertilizer containing nitrogen, potassium, and phosphorus called as NPK fertilizers. Now coming to the micronutrients. The micronutrients we know that which is used in the smaller quantities. Those are called as trace elements. These trace elements are boron, iron, copper, manganese, zinc, molybdenum, chlorine, cobalt, vanadium, and sodium. These are called as micronutrients. The rocks contains the micronutrients. When the soil formation takes place from the rocks, the nutrients are transferred from the rocks to the soil. These are removed from the soil by the crops. These are added to the soil from the atmosphere through irrigation, water, use of fertilizers, and manures. Copper, cobalt, and manganese are present in the big rock. Molybdenum is present more in acid rocks, whereas the zinc is uniformly distributed in various rocks. The function of macronutrients. Okay. Although these are used in smaller quantities, the micronutrients are useful for the plant growth, and some of the important functions are copper is constituted elements, many enzymes that take part in the cellular oxidation. Copper is the one of the metal ion which is present in the enzymes. These enzymes are participating in the cellular oxidation reduction reactions. Some examples of the copper containing enzymes are triminase, urate oxidase, nitrate reductase, and catechol oxidase. are the some of the examples for the enzymes which are involved in the cellular oxidation reduction reactions in the plants. Copper containing plastokinones and plastocyanins are involved in the electron transfer reactions during the primary reactions of photosynthesis. Deficiency of copper lead to the decreased rate of photosynthesis and affects the respiratory oxygen uptake. Zinc, it occurs in rocks. It is approximately proportional to the sum of iron and magnesium present in the rocks. Zinc is an important constituent. It is the constant part of several enzymes, and it is participating in the several enzymatic reactions in the plants. That is alcohol dehydrogenase in yeast, galactose oxidase in molds, and lactose dehydrogenation and carbonic anhydrase in microorganisms and higher plants. Zinc also plays an important role in the photosynthesis and nitrogen metabolism. It regulates the oxygen concentration in the plants. Deficiency of zinc leads to the delayed flower setting and fruit development. Generally, zinc in the form of zinc sulfate is used in the fertilizers. Next, chlorine. Many chlorine-containing organic substances have been found to be the metabolites of many microorganisms. However, no such compounds have been obtained from higher plants. Chlorine is shown to play an important part in oxygen evolution during the primary photosynthesis process. Deficiency of chlorine leads to the um, wilting of the leaf blade tips. Next, cobalt. That cobalt is also micronutrient. It obtained the many microorganisms which are participating in the growth and mild metabolisms. Cobalt play an important role during the fixation of essential nitrogen by the rhizobia of the leguminous and non-leguminous plants. It is a structural component of vitamin B12, cyanocobalamin, which is a which is the vitamin. That vitamin is containing the cobalt is the metal ion, which is essential for the formation of intermediate needed for the nitrogen fixation. Besides, the cobalt plays a catalytic role by activating the enzymes. Iron. Iron is a iron is a constituent of several porphyrin compounds. It occurs in cytochromes, which are known to play an important role in the oxidative phosphorylation during the respiratory electron transport and photophosphorylation during the photosynthesis. Pyridoxine, as iron-containing protein, helps in reduction of carbon dioxide and atmospheric nitrogen and phosphate sulfate. The root nodules of ligneous plants contain a hemoglobin-like protein containing iron. Iron is well known for its catalytic role in enzymatic activity. Succinic dehydrogenase, sulfite oxidase, cytochrome oxidase, catalase, and peroxidase are some of the important enzymes which contain iron. Iron is directly or indirectly involved in all the major metabolic processes of plants. It plays direct role in the photosynthesis in which atmospheric carboxide is transformed into complex organic substances. It is also plays an important role in the oxidative phosphorylation and nitrogen fixation. Deficiency of iron in plants results in the disintegration of chloroplasts and a decrease in the reducting sugars and organic acids. Okay, these are the micronutrients. This is about the introduction and some small history of the plant nutrients and its utilization in the plants. Okay, historical aspects of plant nutrients. Okay, next class we will discuss later things. Thank you.